So I can do this. Does that help? Go better?
I thought you said you didn't want us in the meeting.
During the test, because it was going to sit there and burn your battery. That's just way more efficient than trying to read all three of those matrices to you. If you need to see any of them, let me know. We'll work them out. Remember, to be able to physically combine matrices together, the dimensions have to be identical. Same number of rows, same number of columns from each matrix. Because what we end up doing is adding the positions. Right, so all the positions have to match up if you're going to be able to physically add them. Is that still really small, Dylan? Is that why you're looking that way? Okay. Somebody had a question?
Yeah, what would you write down for, like, so if they, so like whenever you're answering a question and they don't have the same amount of rows or columns, what would you write on your paper
What do we say?
answer that? No solution.
No, it's not a solve. We're not solving anything. It's not an equation.
Okay, so.
What was it? Yeah, undefined, not defined.
Undefined, got it.
So nobody needs to talk about any of those. Page 46. These aren't written so nicely in the book. I will have to either write them down or say them out loud or something like that. These were the multiplication questions. E times D is not defined. Undefined, not defined, same difference. Can't be done.
Can you do 15?
Sure. So we were given C as a 2 by 2 matrix with entries 4 and 10 along row 1, entries -1 and -3 along row 2. And we were given matrix B also as a 2 by 2 with entries along row 1, 5 and -7, and entries -3 and 2 along row 2. And we were asked to find C minus B, the difference between those two. Right? And additive inverse, multiplicative inverses, the reason why I even used that terminology, one of the reasons is to always highlight that subtraction really is adding a negative. It's not a separate operation. Division is multiplying by a reciprocal. It's the same operation. So even though we're thinking subtraction here, we are still combining two matrices. The dimensions must be identically the same, which they are. That also then means my result, my difference, will also have the same dimensions. And I like making a fill-in-the-blank question for it. So especially if you write the matrices kind of in order in which you're going to do the subtraction, when you go to write it out, right, the row 1, column 1 position for matrix C minus row 1, column 1 position for matrix B. When we go to row 1, column 2, the only thing I'm going to be particular about is making sure you don't write minus a negative 7. If you're subtracting a negative 7, we know that that is addition. That's about the only odd thing here. Row 2, column 1 minus row 2, column 1 be negative 1 plus 3. Supposed to be a 5. And then finally, row 2, column 2, matrix A, the entry is negative 3. Row 2, column 2's entry in matrix B is 2. So 4 minus 5 is negative 1. Working along the column, negative 1 plus 3 is 2. Moving now over to column 2, 10 plus 7 is 17. And finally, negative 3 minus 2 gives us our final entry in the matrix, negative 5. So the only thing to be mindful of is don't subtract a negative, don't add a negative, write it appropriately as addition or subtraction. Any others here on page 46? All right, then 54. Any of those? They're not written out so well in the book, so I'd have to either say them out loud or write them out for you. So don't mind doing it. If you took the time to actually answer the questions, we should take time to make sure we're doing so correctly. Well, all right, if you don't have any other questions, let's finish our example on matrix multiplication. We were in the middle of multiplying matrix L times matrix K. If my notes serve correctly, this is where we left off. Somebody double check me. I believe this was our example. Yes? Yes, no, maybe.
Last thing I had written down is
R times S.
That's the last thing I had written.
Did we multiply it all the way out?
Yeah.
Do you have a product? Do you have a product matrix? Does RS equal something?
Yeah.
A 2 by 2 maybe?
Yeah.
Okay, so we did the simple one.
Yeah.
We haven't looked at a more interesting multiplication question. So we will start L times K from the very beginning. All right, this is all stuff that we wrote out last time. It's nothing new, just reiterating when we are able to multiply matrices together. The order with which we're asked to multiply makes a big difference. And normally it doesn't. Normally, if we're just multiplying values together, A times B is going to be equal to B times A. Whether they're negative numbers, positive numbers, decimals, fractions, it doesn't matter. 5 times 7 and 7 times 5 are always the same. With matrices, however, that's not necessarily going to be the case. Most of the time, they're not going to be equal. Sometimes we won't even be able to do one, but we can get an answer for the other. So we have to pay attention to the dimensions, and we talked about kind of writing those dimensions out and being able to take a look at the inner numbers to see if it's possible. The outer numbers tell you what the dimensions of your answer should be. But we only looked at 2 by 2s, so everything matched up very, very nicely. So what would be the dimensions of matrix L? It's a 3 by 2. We count the number of horizontal rows first, then we count the number of vertical columns. What are the dimensions? What's the dimensions then rather of matrix M? The 2 by 3. So if we make sure we're writing it out in order, as long as those two middle numbers are the same, then we are physically able to multiply them together. That's the number of columns from the first, the number of rows from the second. Those have to be the same if we're going to be able to multiply them together. Added trick, the two middle numbers tell us that we're able to multiply. The two outer numbers are going to tell us what the dimensions of our answer is going to be, to make a fill-in-the-blank question. Because as we start multiplying more interesting matrices together, we're still multiplying numbers and adding numbers. It's not like the arithmetic is going to get more complicated. It just ends up being about organization. What numbers are being multiplied? What numbers are going to be added? So anything you can do to help keep yourself clear and organized in what you're doing, I think it's going to help. So our answer is going to be a 3 by 3 matrix. I'm going to start off making, again, a fill-in-the-blank question so I know where all of my arithmetic is going to go. Hopefully, keeping myself from getting confused later on. So if you'll remember, we then take each row from our first matrix, kind of turn it on its side like a column, so that we get these pairs of numbers sitting right next to one another. These are the numbers that we're going to multiply together. But that row 1 from matrix L multiplied by column 1 from matrix M, all of that work is just going to fill in row 1, column 1 in our answer. Right, so row 1 from matrix L, column 1 from matrix M, together will give us row 1, column 1 in our answer. So we will multiply those two pairs of numbers together that are sitting next to one another. But then we combine that multiplication to fill in the one entry. We've now finished column 1. We'll move over to column 2 and do the exact same thing. I'm going to multiply that the entries from row 1 in matrix L. I'm going to multiply those two numbers times the columns in column 2 in matrix M. So 4 times 2 minus 1 times negative 3. And there's absolutely going to be a pattern that emerges, right? If you notice, 4 and negative 1 are showing up in all of my entries along the top row, because 4 and negative 1 are in the top row in matrix L. Move over to the column 3. Got 4 times negative 4 minus 1 times negative 5. We've finished with column 1. I'm sorry. We finished with row 1. We now repeat all of that process now using row 2. And y'all, me circling stuff and drawing arrows, that's supposed to help you know where this is coming from and why I'm moving it there. I'm in no way trying to say that this is what you have to write for work. You're going to have to show me the arithmetic. You're going to have to show me that part. As far as how you know to multiply 4 times 6 and negative 1 times 1, this is me trying to help you get an idea of where it's coming from. How you then deal with that is going to be up to you. So now we've got negative 2 being multiplied by 6. We're going to add that to 3 being multiplied by negative 3. Sorry, 3 times positive 1. Right, so now we'll see a pattern that's going down a column. We noticed going across a row, 4 and negative 1 showed up in every row. Well, now along the column, you can see that 6 and 1 are going to show up in all of the entries along column 1, because those are the entries in column 1 in matrix M. So if you pick up on that pattern, you don't have to do all of this drawing stuff out to the side. Right? Negative 2 and positive 3 have to show up in everything going across the row. The 2 and the negative 3 in column 2 have to show up in all of your work along that column. Right, so if we write out all of our work, we're seeing the same numbers being multiplied in the exact same positions. Hopefully that helps you see the organization. Hopefully it helps you stay organized in doing this arithmetic.